Okay, now for the next set of videos, part 2, we have solve some log equations. Again, this is still from 4.6. So on this one, you need to be real careful because these logs are split apart. We have log base 3 of x plus log base 3 of 2 equals log base 3 of, in parentheses, 3x minus 1. Now this one's okay. It's in parentheses there already. But this is split apart, and the way that this property works is based on your exponent laws. So we need to follow the rules here. We need to combine these up together. So we're going to combine our logs by compressing them or squishing them together like we did in the log property unit. So I'm going to write a note here. It's really important that you combine, or I think I called it squish in one of the videos, logs first before you exponentiate. Okay, that's really important, or it will not come out to be the same answer at all. Okay, you'd be kind of breaking the rules. You can't, what people want to do is just go like 3, 3, 3 like that. You can't do that. You have to push these together first. So we have log base 3, and then we're going to use our product to, or sum to product, 2x. Okay, so you just have to compress those together first, and then you can exponentiate. Okay, it's kind of like you simplify each side before you start the process, right? So 3, 3. Now I can just do that, and I get 2x equals 3x minus 1. And you can see where that would have come out a lot different. That would have been x plus 2. It would have been left that way, and that would not be correct. So then we have negative x minus 1. So x equals, whoops, it's negative 1. X equals positive 1. And then again, just make sure you check the domain. So I'm going to look up here. I'm good there for positive 1. I'm good here. I have 3 minus 1 will give me 2. Okay, and so if I were to look here, that would work out. Okay, and if I were to calculate out with a calculator each side of this in my check, if I did log base 3 of 1 and log plus log base 3 of 2, I would get the same thing here, log base 3 of 2. Okay, because we know that anytime we have a 1 there, it's going to be 0. Anyway, so now we have, so actually I don't even need a calculator. Now we have a similar one, and again, I want you to think about this. This is split apart. It's not simplified as much as it should be because I have this minus in there. So I need to make it be like one log equal to another log before I exponentiate. That's another thing you could think of it as. It must be in the form log base b of x equals log base b of y before we exponentiate. Just like the way back at the beginning, if you recall, this was what we're okay to do, not anything else. Okay, so there's some moving parts here, but you can handle that. So go ahead and try that as classwork and see how you do. It's a little more complicated because it comes out as a quadratic. I'll just give you that hint. Okay, so I've started this one off for you so you can get going in the right direction. So again, you need to combine or squish your subtract together. That's expanded. So we're going to write this as a division. X over x plus 1 equals log base 5 of negative 2x. Then we're going to exponentiate. Okay, so then we're left with x over x plus 1 equals negative 2x. Now from there, you're going to clear your denominator and solve it as a quadratic. So go ahead and pause the video and try that. Okay, so once you clear the denominator, you're going to end up with x equals negative 2x squared minus 2x. Get everything to the left-hand side set equal to 0. 2x squared plus 3x equals 0. Then factor x times 2x plus 3 equals 0. So we have x equals 0 or x equals negative 3 halves. But we need to check and see if that works for our domain. So if we have a 0 up in here, right off the bat, we can tell, no, 0 is not going to work. It'll make it be 0, or it has to be greater than 0, remember, to be in there. So same thing here. Okay, we'd have a 0. We can't have that. And we also cannot have a negative. So if we had a negative 3 halves in the numerator and a negative 3 halves here, we would have, let's see, negative 3 halves, and then we would have a negative 3 halves plus 1. So that's going to work out to be negative 3 halves over a negative half equals negative. Actually, I'm catching myself before I go into any of that, because what did I do? I looked at what I compressed rather than the original. So that's kind of good that happened. So we point out when you're checking against the domain, you've got to check back to the original, right? So check up here. So the 0 fails right here and here. Now the negative 3 halves, that fails. That also fails right here for the x. And for this one too, it would be okay for that, but has to work for all of them. If any of them end up being not in the domain, then we can't have that one either. So we would say no solution for this one. So we just have, let's see, this one on the left over here, 3 to the x plus 1 equals 4 to the 3 minus 2x. Now this one is a tricky one. It's kind of complicated to do it without crunching any numbers and keeping it as an exact answer, because we have 2 different bases. Now we can still take the log of both sides. If we have 2 different bases, we can't just, what we can't do is just say, oh, these exponents are automatically equal, right? So our process is a little bit more cumbersome. So we are going to do the log of both sides. Now you can choose to undo one or another, or you could actually just do common log and see how that works out. But I'm going to do it as log base 3 of both sides. Here, I'll rewrite this. Log base 3 of 3 to the x plus 1 equals log base 3 of 4 to the 3 minus 2x. So this one works out kind of nicely. So I get the x plus 1 left equals my log base 3 of 4 to the 3 minus 2x. Now I'm just going to say put these in parentheses here when you're using the properties too. So I'm going to actually bring this down. I'm going to use that property there where I can bring that down in front as a coefficient. 3 minus 2x log base 3 of 4. Okay, so now what I want to do to simplify is to distribute this to that log base 3 of 4. So in my next line, I'm going to have x plus 1 equals 3 log base 3 of 4 minus 2x log base 3 of 4. And what I'm trying to do at this point is get x by itself. So I'm following that pattern, the same pattern we would use for solving literal equations. We would get free up the variable by distributing, right? And then get all the x stuff to one side. So now I'm going to do that here. I'm going to add this 2x log base 3 of 4 over here. So that's going to be x plus 2x log base 3 of 4. And then I want to subtract this 1 from there, right? So I'm going to have it equals 3 log base 3 of 4 minus 1. Okay, so I added this to both sides and I subtracted 1 on both sides. So now I've collected up my x stuff on the left, and now I just need to factor out that x. So it's the same process we did with literal equations. Now be careful here, make sure you do put that 1 in. Sometimes people just kind of drop that off. You've got a lot going on in this problem, so it's easy to lose a piece here and there. So go back and kind of check it over. And now I have that same thing on the right side. So now I can divide both sides by this stuff here. 1 plus 2 log base 3 of 4. 1 plus 2 log base 3 of 4. Okay. And so my answer is going to be x equals 3 log base 3 of 4 minus 1, all divided by 1 plus 2 log base 3 of 4. Now sometimes on the key I put it as just a generic base. Depending which route you went, it depends on how your answer comes out. But you can figure it out if you wanted to use the change of base formula. You could do that. You could just ask me. The pattern would be similar if you had exponentiated with a base of 4. It would be similar. It'll just be kind of rearranged. So that is a bit tricky. Try your best with those. Try to keep it as an exact answer. But if you want to estimate out, you can round and crunch those numbers. And usually you do it, just start with a base 10 for those. But that gives you really good practice manipulating, and it's a really good review of just overall skills from the course, especially that literal equation stuff too, because you'll see that on the final. Now we're looking at this page, the next page here, log of x plus log of x plus 21 equals 2. So we did one kind of similar earlier. It was probably similar to this one with the, we had a subtract. Now we have an add. Whoops. So maybe you could try that one as a classwork, but just be careful. Remember to follow your rules properly. You got to compress it together first. It does come out a little bit complicated because it's a quadratic, but it is factorable. I'll tell you that. Or you can, you can always use the quadratic formula if you need to, but I think it's easier to factor on that one. You get some nice numbers to work with. Let's see the next one. That's a little different setup, so I'll do that one with you in a minute. So try this one. I'm going to write it up and then check back. Okay, so you should get an answer of x equals 4. What I did was compress this first. I'm going to do, or combine it. Log, it's base 10, so sometimes that's helpful to write that in so you don't inadvertently just pick something else. for your base. So you're going to do log base 10 of x times x plus 21, because remember I'm doing the sum to product, right? That property. It's really important to know those properties because you can reference your notes. I mean, make sure you get them right, of course, but also it's just important that you know them in your head, you just memorize them, because otherwise you're always kind of hunting around and searching. But if they're in your brain to pull out, it's a lot easier. But definitely double check. And then so I have this, I had a base of 10 that I exponentiated, so I raised did 10 to the second power here, so that becomes 100. This I just distributed to get my x squared plus 21x, and then I subtracted that 100. I kind of skipped a bunch of steps here, but I think you can handle that. You know that this is set equal to 100, and then I subtracted 100 to set equal to 0, because I have to do that before I factor. And then I factored, and I got x equals negative 25 or x equals 4. So the negative 25, when I check back into the originals, not going to work anywhere. So my answer is 4. 4 is fine. That's in the domain. And if I were to crunch those numbers there, I would have log of 4. And you could do this on a calculator. You could check it. Log base 10 of 4, you just hit the log key and 4 and enter, plus log of 25 is going to equal 2. So you can kind of check that out on your own just to make sure if you want to do that. So this one on the right hand side is a bit different. Maybe you picked up on the difference. Maybe think about, what is that difference? So if I'm looking at this one on the left, I see that I have my logs on one side and my number stuff on the other side. So that's where this one's different. I have logs on both sides. So I want to collect up my logs to one side, because I think that's going to be easier to work with, especially because I can't deal with this. I have to remember it has to be one log equal to log before I can exponentiate. So if I get my logs together on one side, then I can combine or squish those together using my property of the difference to quotient. So here we have ln x, I'm going to do minus ln x minus 1 equals 1. So now I can combine these. So that's the purpose. And it's subtract, so I'm going to do it as a division inside the parentheses there, ln x over x minus 1. Now from here, you're probably fine. Once I exponentiate, I'm going to just write that as e to the ln of all that stuff, and e to the 1 over there. So I'm going to be left with x over x minus 1 equals e. This one's kind of huge, so a little smaller. And then we're going to clear the denominator, x minus 1 times x minus 1 on both sides. And we get x equals ex. Remember, e is a number, not a variable, minus e. And then I want to collect up my x stuff to one side. So I get x minus ex equals negative e. Then I factor out my x. I get x times 1 minus e equals negative e. Now I'm going to divide both sides by 1 minus e, and I get x equals negative e over 1 minus e. And you can leave it that way, or that also equals e over e minus 1, which is kind of a nicer format. Okay, all I did was multiply top and bottom by negative 1 and kind of rearrange stuff. for that. So I'll just show you that really quick. I could go -1 over -1 because it's really like multiplying by 1. I can do that balancing act. And then I get e over -1 plus e, which then equals this. Okay. Okay, now this next one, I have, logs in multiple places, but on the right-hand side, I only have it as 1 log, so I'm good. But remember, I have to have it be equal to 1 log, equal to another 1 log before I exponentiate. So these I have to combine up, and I want you to try that and do that one as a classwork. And I'll write it out, and then I'll go over it briefly with you. I'm just gonna kind of mark this problem off here. So pause the video and give it a go. You even might like to do stages with it, like kind of check back in between and kind of drag the video. So first stage would be to use that sum to product, but I have a quadratic in here. So that makes it a little more fun. Now I'm going to exponentiate. I have a base 2. So then now I'm at this point where I have x plus 4 times x plus 2 equals 3. So I'm just going to calculate this out as I go. Okay, so now we're at the point where we have the answers. What I did was just 2 log base 2 are inverses, so that leaves us with the what's inside the parentheses. So I calculated that out just by foiling x squared plus 6x plus 8. And then over here I have just plain 3 because those undo each other. Then I set that equal to 0. So I have x squared plus 6x plus 5 equals 0. Then I factor to be x plus 5 times x plus 1 as binomials equals 0. Then my results are x equals -5 or x equals -1. Now, I was like, oh, negatives, I don't know, is that going to work? But right off the bat, I can't assume a negative is not going to work because these have operations involved in them. But I do need to go check back to the originals, right? So I'm going to test the 5. So -5, or the -5. -5 plus 4 would give me a -1 there. So that's no good. Even if it worked for that one, it would be no good because overall it has to work for all of them. So that one's out, but let's take a look at the -1. So if I put -1 in there plus 4, I will get a positive 3, and a -1 plus 2 gives me a positive 1. So I'm good with the -1. But the other one's extraneous. So make sure you check. So you want to get all the points you can for those. All right, so last one of this part 2, we have e to the x plus 4 equals 5 to the 2x minus 1. So this, again, we don't have like bases here, but that's okay. We can still just take the natural log of both sides. And later on, you'll be approximating, especially in a word problem, you're going to have lots of them that end up kind of looking like this. So we're going to take the natural log. Let's start with that. ln of e to the x plus 4. And I want to pick natural log because that's the inverse of e. And then natural log, but don't forget to do it on the other side. Sometimes people forget that. 2x minus 1 in the exponent there. And then put that in parentheses because that's going to have to come down as a coefficient on this one. So you want to make sure you distribute. This one's probably okay, but so that leaves us with x plus 4. I just kind of put a line through there. I just want to know, I mean, it's not disappearing, it's undoing. So it's the inverse that leaves us with the x plus 4. If you think back to the properties we were doing before, that is how it works. So it's just my shortcut way of tracking. And then I have this comes down again, another little shortcut way of tracking the property or trying to show you what I've gotten rid of. But we have to put in parentheses 2x minus 1 in parentheses ln 5. That's really important. And now I'm going to have to distribute just like I did in that other problem. There was a similar one. So I'm at the point where I leave this x plus 4. That doesn't need to be in parentheses right now. And then I have 2x times ln 5. And then it's a minus ln 5. Okay. Now we need to collect my x stuff to the one side. X minus 2x ln 5 equals minus ln 5 minus 4. So I'm going to bring that over. Now, I think these are fun. It's kind of like a puzzle. I get into it. Hopefully you like it too. Everyone's always so afraid of logs, but I think they're just fun. So we have x. I'm going to factor out 1 minus 2 ln 5, just like we did with literal equations. So again, if you have the building blocks, it's really just the same thing you've kind of done before. Then I'm going to divide both sides by the 1 minus 2 ln 5, 1 minus 2 ln 5 on that side. And then that leaves me with x equals ln, that's a negative ln 5 minus 4 over 1 minus 2 ln 5. Now I can kind of rearrange this to not have all that negative there. I can multiply top and bottom by negative 1 over negative 1. Have to do top and bottom because I don't want to break any, kind of math rules there. And then this will become, if I distribute that through, I would get net ln 5 plus 4, right? Because you have to distribute. And then on the bottom, I would get a negative 1 plus 2 ln 5. And I would want to maybe rearrange that. I could actually bring this exponent up. So I could have it be ln 5 plus 4 over ln 25, because this is 2 ln 5 is really ln 5 squared, right? Minus 1. So that's kind of my most streamlined result. And then I can crunch the numbers. If I wanted to, I could just type that in a calculator and you would get about 2.528. And I'm showing you that just, well, actually, I would round. Let's see. I think I round to the nearest hundredth is usually what I have you do. So then we would do 2.53. So I'm showing you that because for word problems, you can do that. If you did it on a skill problem, then you probably aren't going to get full credit. We want to have it be exact answer for skills. So rounding's okay for word problems. All right, so I'm just putting a note there. So thanks for watching. Have a great day. I'm going to do one more video. No, probably 2, because we have some word problems, graphs and word problems to deal with too. So long couple of sections, but you guys are doing great. We're almost done with the whole term. So have an awesome day.